Hello there, and welcome to The Curious Dreamer. If you like to fall asleep to gentle science and quiet wonder, you're in the right place. Tonight we're journeying through the planets, from diamond worlds that sparkle in darkness to stormy giants with winds faster than sound. We'll visit glowing skies, endless oceans, and lonely worlds drifting through space with no sun to call home. You don't need to do anything. Just breathe, relax, and let curiosity travel for you. This is your moment to unwind, to fall asleep among the planets. Now, let's begin. To understand the mind-boggling extremes of our universe, let's dive into a reality that feels more like science fiction. Planets that burn hotter than stars. Imagine a world where temperatures soar above 7,000 degrees, easily outpacing the fiery surface of red dwarfs, which are typically some of the hottest and most commonly found stars in the universe. It's a perplexing thought. What does it mean for a planet to burn hotter than the very celestial bodies we consider to be the source of all heat and light? Take Kelt 9b, for instance. This exoplanet resides in the constellation Cygnus, orbiting so tightly around its host star that it will have you questioning the very nature of what we understand about planetary systems. With a surface temperature that can reach mind-blowing levels, Kelty 9b creates an environment where its atmosphere is literally boiling off into space. It's as if this planet has been placed in a cosmic forge, glowing brighter than fire itself. Just picture yourself standing on the scorching surface of Kelt 9b. Your skin would feel like it's melting under the relentless heat. You can see the atmosphere shimmering and contorting like a mirage, and the colors, oh, the colors. They would be a surreal blend of fiery oranges and reds, bleeding into vivid yellows, giving the whole landscape an otherworldly glow. You might even imagine what it might be like to walk across such an extreme landscape where the ground feels like heated metal beneath your feet. A level of intensity that we on Earth can only comprehend through thermodynamics or science fiction. What's perhaps the most fascinating part of Kelt 9b is that it challenges our basic understanding of the universe's structure. Typically, within the cosmic hierarchy, we consider stars to be the energy powerhouses. They illuminate and heat nearby planets, but Kelty 9b flips this narrative on its head, standing out as a testament to how varied and unpredictable our universe can be. Being so close to its sun, think of how hot it would be to bask in the glow of a campfire, but imagine that intensity magnified 1,000 times, with the heat warping reality as we know it. Yet, against the backdrop of this chaotic radiance, some questions arise. How do planets like Kelt 9b even form in such a volatile environment? What cosmic dance leads to these searingly hot worlds, where atmospheric molecules clash against intense radiation and heat until they can no longer hold themselves together? It's a stunning reminder of the forces at play in the cosmos, forces that are every bit as compelling as nor we can imagine. In a broader context, Kelty 9b and its ilk invite us to rethink our preconceived notions of habitability. We often associate life with temperate conditions, a planet nestled within the so-called Goldilocks zone, where temperatures are just right. Not too hot, not too cold. But these scorching giants push the boundaries of our comfort zone and, in doing so, challenge our ideas of what constitutes a planet versus a star. With atmospheres that essentially vaporize into space, could there be forms of life we can't yet conceive of, adapted to thrive in such harsh conditions? And this prompts a reflective pause as we think about our own place in the universe. It lends perspective to our daily issues, reminding us of the vastness and the extreme conditions that exist beyond our cozy blue planet. Earth, with its moderate temperatures and nurturing atmosphere, becomes a precious jewel amidst a vast cosmic sea of extremes. So, while we sit in the comfort of our rooms, watching the stars twinkle from afar, let's hold those thoughts close. Enjoy the warmth of our own star, the sun, one that safely bathes us in light without scorching us to a cinder. And as we wonder about planets like Kelt 9b, remember that the universe is brimming with discoveries, just waiting to change the way we think about life, heat, and atmosphere. The surprises don't stop there, because as we venture into the depths of space, beyond the known planets, we encounter realms that rewrite the stories we tell ourselves about what is physically possible. Prepare to explore even more thrilling extremes as we look further into this fascinating universe of ours. What else awaits beyond these scorching hot planets? How do they fit into the delicate fabric of space? Hold tight. We've just scratched the surface. Let's journey into the cosmos and explore the mesmerizing concept of diamond planets, focusing on the fascinating 55 Cancri E, often referred to as the Diamond Planet. Imagine, if you will, a celestial body where the very earth under your feet could be composed of solid diamond, the stuff of dreams, or perhaps the ultimate luxury. 55. Cancri E orbits a sun-like star located a mere 40 light-years from Earth in the constellation Cancer. While many of us might think that diamonds are merely luxury items found in jewelry stores and at glitzy events, on this distant exoplanet, they could very well be a fundamental part of its geology. Isn't it incredible to think that what we value immensely as gemstones might actually exist in abundance on another planet? To appreciate the grandeur of 55 Cancri E, we must first understand its environment. This exoplanet possesses a carbon-rich composition, which is key to the formation of diamonds. In the universe, elements don't exist in isolation. They interact under extreme conditions. On 55 Cancri E, immense pressure exists, possibly dozens of times greater than Earth's atmospheric pressure. Just picture that for a moment. Forces so strong they could reshape carbon into crystalline structures that glimmer like countless stars in the night sky. Visualize scaling one of the imaginary mountains made of diamond. As you ascend, sunlight strikes the intricately faceted surfaces. Rather than a typical landscape, you find yourself in a dazzling wonderland where light dances in spectacular displays, fracturing into vibrant spectrums. The stark contrast of this rugged terrain against the shimmering brilliance could evoke feelings of awe and wonder. We often seek beauty, and here it is, conceived not from nature's ordinary patterns, but from the extraordinary processes of cosmic chemistry and physics. The conditions on this planet differ radically from our experience on Earth. Temperatures can soar well beyond 2,000 degrees Fahrenheit, painting a surreal picture of the planet's surface. One might imagine walking on diamondified land while feeling the burn of an intense atmosphere. Yet, that diamond-layered surface reminds us of the infinite possibilities of our universe. It forces us to confront two stark truths: the harshness of environments far removed from our own, and the stunning beauty that can arise amid those extremes. Now, while 55 Cancri E is fantastic to ponder, it also stirs our curiosity about life beyond our world. In our everyday lives, we often associate diamonds with love, magic, and eternal bonds. However, life on a planet that seems to embody permanence in one of its most prized materials poses the question: What does eternity truly mean in a place detached from our experiences of time and relationships? Taking that a step further, think about how we define value here on Earth. We tend to equate diamonds with status, wealth, and societal standing. In a universe where entire planets may be composed of them, how might our understanding of value shift? Would we still cherish diamonds if they were as commonplace as pebbles? Suddenly, these radiant gems become mere artifacts of survival, overshadowed by the other, more profound wonders they might signify. It's easy to romanticize a diamond planet like 55 Cancri E from a distance, focusing on its glittering potential. But the truth remains that it also reflects humanity's deep-seated desires, our search for beauty, worth, and meaning, even in the cold expanse of space. This contemplation transforms the diamond planet into a mirror reflecting our values, aspirations, and perhaps the innate human craving to discover and appreciate beauty where it seemingly should not exist. As we continue to push the boundaries of our cosmic exploration, we realize that the universe still has many secrets waiting to be uncovered. The existence of planets like 55 Cancri E invites us to consider not only the marvels of the universe, but also our place within it. If diamonds can form under such extraordinary conditions, what other breathtaking phenomena might await our discovery beyond the familiar skies of Earth? In conclusion, embracing the concept of diamond planets like 55 Cancri E enriches our understanding of the universe and ourselves. It urges us to look beyond the horizon, to seek wonder not just in what we see, but also in what we have yet to understand. And who knows, perhaps one day, as humanity continues to evolve in our quest for knowledge, we will venture to places where surreal landscapes of diamond bright await. A world where every step taken shines under a silvery sky, reminding us that the universe is as rich and varied as we dare to imagine. Imagine standing on a distant planet, the air warm and fragrant with unusual flora as the two suns begin their graceful descent toward the horizon. Your heart races as you witness something remarkable. The sky transforms into a vivid tapestry of gold and red, a dazzling blend of colors shifting fluidly as each sun casts its radiant light in different directions. The moment draws you in, feeling surreal yet exhilarating, like stepping into the fantastical landscapes of your favorite sci-fi movies. This isn't just a whimsical daydream. It's the reality for some exoplanets that orbit two suns, an extraordinary phenomenon known as circumbinary planets. Located light years away, these distant worlds are caught in a cosmic dance, revolving around twin stars. Their existence evokes wonder and curiosity, provoking thoughts about what life could thrive there amid the double shadows and twin sunsets. Take Kepler 16b, for instance, a planet that's perhaps the most famous example of a circumbinary member. Discovered by NASA's Kepler mission, Kepler 16b is larger than Saturn, and it orbits a binary star system. Picture the scene. As twilight descends, the light from the two stars filters through a thick atmosphere, illuminating the landscape with hues that the earthbound eye has never seen. Would you feel weightless, drunk on the colors swirling overhead? Might the flora respond, unfurling in shades of violet and indigo as they rise to greet the dual sunset? What's even more fascinating is how this unique orbit affects the climate. On Earth, seasons follow predictable patterns based on the tilt of our planet and its single sun. But on a world where two suns reign supreme, the patterns may fluctuate dramatically. The rhythm of day and night would vary, sometimes plunging the landscape into prolonged daylight or an extended dusk, an alien experience to our single-sun existence. Imagine a peaceful evening, the warmth of the suns slowly fading as they dip below the horizon, casting elongated shadows of trees and hills that seem to dance alongside you. As you walk, your feet crunch against exotic soil, and intermittently, you look up. Would the sky appear as though it is on fire? With so many variables at play, the atmosphere could brim with life, both in the ecological sense and in a cultural one, should intelligent beings exist on such a planet. How might the inhabitants interpret this natural symphony? Would their poets write verses about the day the stars align to create golden hour, a moment shared between two suns gently setting? Perhaps their artists depict dual sunsets through vibrant canvases, each stroke a celebration of beauty, a beauty that, for us, can only be imagined. But the concept of two suns opens a portal to more than just breathtaking views. It raises profound questions about the nature of life itself. We speculate on what kind of adaptations might evolve under the gaze of two blazing stars. Would the plant life develop differently, perhaps thriving in cycles synchronized with both suns? Would creatures evolve with unique adaptations to navigate this world, their eyes possibly equipped to detect the dance of light more acutely? Moreover, how would human perception change if we lived on a planet like this? Our experiences here on Earth, defined by a singular sun, convey a certain sense of normalcy. However, imagine the influence of a second sun on human culture. A new mythology emerging, telling tales of celestial beings that watch over the world from the heavens. Social structures might revolve around the timings of dual sunsets. Festivals could celebrate the moment when day transitions to night, marked by both suns kissing the horizon simultaneously. In literature and visual storytelling, the allure of dual suns often captivates audiences, showcasing them as cosmic metaphors. They symbolize balance, duality, and the various dimensions of our existence. They remind us that even in the vastness of space, contradiction can yield beauty. As we venture deeper into the cosmos, scientists continue to scan the skies for more circumbinary planets, mapping out the potential for life amidst the stars. Each discovery brings us one step closer to understanding our place in the universe, encouraging us to dream, explore, and redefine our notions of home. In the end, it's not merely about the colors painting the night. It's about the stories we weave and the connections we forge. The imagery of two suns ignites a spark of imagination, bridging the gap between what we know and what might be, continually urging us to seek out the wonders that lie beyond the shadows of our own world. So, the next time you gaze up at the sky or watch a sunset, think of those extraplanetary realms where twin suns rule. Let your mind drift to those worlds where the impossible becomes possible, and the beauty of the universe continues to inspire awe and adventure in all of us. As we journey into the extraordinary realm of exoplanets, our next stop is a breathtaking celestial body known as HD 1189733b. At first glance, this distant gas giant may seem like a jewel shimmering against the cosmic backdrop, its vibrant azure hue captivating even the most seasoned stargazers. However, beneath this deceptive beauty lies a world where danger reigns supreme, painting a portrait not just of alien landscapes, but of extreme conditions that are anything but hospitable. Imagine standing on the surface of HD 189.733b, looking out at a scenery that appears calm and inviting. That gorgeous blue color doesn't come from tranquil oceans. Instead, it's the result of a thick atmosphere composed mainly of silicate glass and clouds of vapor. But as we peer closer into the atmosphere, a different picture begins to emerge, one filled with chaotic winds and brutal storms. Here, winds whip at an unimaginable pace, reaching thousands of miles per hour. Visualize that. Winds traveling fast enough to tear through metal, ripping apart anything unprotected. The atmospheric pressure alone is enough to crush submarines, but the real menace comes from what those winds carry. Shards of molten glass, hurled sideways in a violent ballet of destruction. Now, can you imagine taking a walk on the streets of your neighborhood and suddenly being pelted by razor-sharp glass flakes, all while trying to keep your balance against hurricane-force winds? It's a surreal image, one that we can hardly fathom, yet it's the reality on this planet. As you stand there, gazing at the sky, this glass rain paints a hauntingly beautiful picture, each shard reflecting light like shards of a shattered prism. From afar, it's a glittering spectacle, a visual deception that belies the peril it harbors. It's reminiscent of experiences we all have in life, isn't it? We often encounter situations that seem wonderful and beautiful at first, only to reveal dangers we never anticipated. Take a moment to consider your own life experiences. Have you ever chased after a goal that seemed perfect and glittering, only to find the journey fraught with challenges? Maybe it was a career change that looked promising on paper, yet thrust you into chaos. Or perhaps it involved a relationship that appeared idyllic until the flaws became glaringly obvious. HD 189.733b serves as a cosmic reminder that elegance can often conceal harsh realities. The storms on HD 189.733b are relentless. They sweep across the planet constantly, a raging tempest swirling against a backdrop of deep blue. The power of nature here is unleashed in a way that's profoundly humbling. No structures could withstand the fury of these winds. No life form as we know it could endure the lethal glass rain. And yet, scientists find fascination in this brutality. Why? Because it challenges our definitions of what life can be and where it can thrive. It drives us to ask fundamental questions. What does resilience look like? What adaptations are necessary in the face of insurmountable odds? The allure of HD 189.733b lies not just in its unforgiving beauty, but in the lessons it evokes. It reminds us that adversity isn't a deterrent. It can be a catalyst for growth. Just like the shards of glass slicing through the air form a wild and fiery dance, our own battles can lead to a more profound understanding of ourselves and the universe around us. So, as we continue to explore the cosmos, let's not forget the lessons of this glass rain planet. It encourages us to confront adversity, to not be swayed by appearances, and to embrace the stormy experiences of life, acknowledging the beauty and brutality of our own journeys. And much like science, with its complexities and mysteries, our lives are woven into an intricate tapestry where challenges create resilience, forging strength and wisdom that burns as brightly as the molten glass on HD 189.733b. Can we ever truly know what it would be like to live in a place where beauty can become deadly within moments? Perhaps we can't. but we can certainly reflect these experiences onto ourselves as we navigate the landscapes of our own lives. The next time you face a challenge, think of HD 189-733b. Embrace those storms with an open heart, recognizing the brilliance hidden within the chaos, and know that despite the dangers, the beauty of existence is all around us, waiting to be discovered. As we cast our gaze upon the cosmos, we often envision vibrant landscapes, rocky terrains, or the swirling clouds of gas giants. Yet, nestled far from our Earth-centric perceptions lies a collection of celestial bodies that might change how we define habitable worlds. Welcome to the realm of ocean worlds, planets and moons shrouded beneath vast oceans that extend thousands of miles beneath their surfaces, concealing mysteries that stretch across the cosmos. Imagine a planet entirely engulfed by water, its surface glimmering under the distant sun like a colossal sapphire. Ocean worlds are more than just water. They are ecosystems ripe with possibilities. The idea of a global ocean is not just a theoretical construct. It has been confirmed in several celestial bodies, including Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn. Both of these ice-covered worlds harbor vast, hidden oceans beneath their icy exteriors, sparking the imagination about what life could flourish in such extreme conditions. Consider Europa, where beneath an ice shell estimated to be about 15 to 25 kilometers thick, lies a subsurface ocean that may be twice the volume of all Earth's oceans combined. The environment here is thought to be dynamic, with the potential for hydrothermal vents similar to those found on Earth, where life thrives in complete darkness, fueled by the heat of volcanic activity rather than sunlight. These vents could modulate heat and chemical nutrients, creating microhabitats where organisms could flourish, much like the extremophiles we find in our ocean's depths. Those incredible life forms that thrive in conditions once deemed inhospitable. Now, let's turn to Enceladus. This icy moon is not merely a barren rock. It actively ejects plumes of water vapor and ice particles into space, offering tantalizing glimpses into its subsurface ocean. Analyzing these plumes through missions like Cassini allowed scientists to discover the presence of organic compounds, building blocks of life. Imagine a world where, beneath the pressure of thousands of kilometers of water, complex molecules interact, potentially creating the right conditions for life to emerge. It's captivating to consider how alien biology could adapt to live in these water worlds, possibly resembling Earth's own bizarre creatures. Picture massive squid-like organisms drifting through the ocean currents, phosphorescent in the dark, or perhaps coral-like structures adapted to feed on the rich minerals spewing from the ocean floor. The diversity of potential life forms could challenge our preconceived notions of life itself. Yet despite their allure, other ocean worlds may remain silent, vast, and empty. Take Triton, Neptune's largest moon. It is believed to have a subsurface ocean, yet its surface presents a harsh, frozen landscape that lacks the signs of life found in Europa and Enceladus. Here, we encounter an ocean world that does not cradle vibrant ecosystems, but instead reflects the stark reality of a universe indifferent to our desires for companionship. The tides of Triton may surge and ebb, but what if they're merely washing over cold, lifeless depths? This duality within ocean worlds, the tantalizing potential for life alongside the stark stillness, sparks an emotional resonance within us. There's something so profoundly relatable about the idea of longing, even in an infinite universe. We yearn for connection, and as we contemplate the dark, deep oceans of alien planets, we're inherently driven to ask, are we truly alone? Or is the universe teeming with unknown life, just waiting for us to discover it? The notion that beneath the shimmering surfaces of oceans, vast and deep, life, or the remnants of a once thriving ecosystem, might exist, creates a sense of wonder tinged with solitude. This is what unites us as human beings, whether we're walking the beaches of Earth or contemplating distant worlds. Our quest for understanding feels like a mirror reflecting our innermost desires. Ocean worlds also remind us of our own blue planet. Earth is a unique case study, a landmass flourishing amidst water. With 71% of our surface covered in oceans, we rely on these vast bodies of water for life itself. As we explore other ocean worlds, we cannot help but reflect upon the fragility of our ecosystems. What does our experience say about the likelihood of life elsewhere? The presence of water is often heralded as a promising sign when we search for habitability in the cosmos. Yet, can we write off worlds like Triton or the mysterious depths of Ganymede, another of Jupiter's moons, simply because they appear barren? The potential of ocean worlds extends beyond just the search for extraterrestrial life. They provide a unique perspective on the processes that govern planetary systems and the conditions that can lead to habitability. Scientists now hypothesize that even icy moons, with their freezing temperatures and violent environments, might offer crucial insights into basic biological chemistry, the very essence of life. Unraveling the secrets of these distant oceans may also inspire innovations here on Earth. How can we learn to harness energy from hydrothermal vents or better understand climate dynamics by studying other oceanic bodies? Ocean worlds could ultimately steer us towards new solutions for sustainability or pave the way for future explorations of our solar system and beyond. Just as the tides ebb and flow, our fascination with ocean worlds continues to rise. Every mission, every discovery draws back the curtain on these breathtaking environments, setting the stage for a cosmic adventure with boundless possibilities. Each ocean world stands as a testament to the diversity that exists within our universe, urging us to reflect on the delicate balance of life that exists on our own blue planet. The next time we think about ocean worlds, let's embrace both the curiosity they incite within us and the serene solitude they embody. Whether they're filled with life waiting to be discovered, or simply vast, tranquil stretches of nothingness, each ocean world serves as a reminder of the wondrous unknowns that still beckon us in the cosmic sea. The exploration of these hidden depths might one day reveal not just new worlds, but also a deeper understanding of our own place in the universe, a reflection we are all a part of, searching for meaning across the endless skies. In the vastness of the universe, there are remarkable worlds that tell a story through their unique dance with their stars. Among these celestial bodies, tidally locked planets have emerged as captivating subjects of study. Imagine a planet that forever faces its sun. One side is bathed in relentless daylight, where scorching temperatures can soar, scorching deserts stretch out under an unending sun, and the other side is cloaked in perpetual darkness, a frigid expanse that's frozen in time. The emptiness may seem stark, but this is not the whole picture. Picture yourself standing on this alien world, On the sunlit side, you'd experience a radiance that never dims. The landscape could be alive with vibrant ecosystems adapted to the relentless light. Plants towering like skyscrapers flourish, photosynthesizing tirelessly in that everlasting daylight. Imagine the colors, brilliant yellows, greens, and reds, as life taps into the near-constant sunlight. Yet with such intensity, life also faces a challenge. The scorching heat could drive many species to develop clever survival strategies. Perhaps there are creatures that burrow into the ground during the most intense hours, emerging as dusk begins to settle in the twilight zone. Now, let's move to the dark side of our tidally locked planet. Here, a different kind of existence unfolds. In this frigid darkness, temperatures plunge, and the eeriness of twilight lingers just beyond the horizon. But life finds a way, adapting in surprisingly ingenious methods. Maybe there are bioluminescent organisms glowing softly in the shadowed landscape, or hardy, warm-blooded creatures that might huddle close to geothermal vents lurking beneath the icy surface. Their ability to draw energy from the core of the planet opens up fascinating possibilities for survival in this stark and intense environment. The most intriguing aspect of tidally locked worlds lies in the narrow twilight zone that separates the searing light from the chilling darkness. This transitional area, where sun-soaked day meets starless night, may hold the perfect environment for sustaining life. Given its moderate temperatures and balanced light, one can imagine a paradise where stunning flora and fauna converge. Imagine walking into this twilight realm. Soft hues of purple and amber stretch before you, and the air is a rich tapestry of scents. Floral notes hinting at life flourishing just out of sight. Rippling whispers from creatures that have evolved specifically to thrive in these precarious conditions. The delicate balance of the twilight zone might foster a range of ecosystems. It could be filled with shrubs that open their leaves to catch the sun, yet possess a reflective surface to shield from the intense rays, evolving to graze the lines between light and shadow. Perhaps there's a food web here, intricate and amazing, where life supports life, communities existing in a world often overlooked by the rest of the planet. But the dynamic nature of these worlds introduces questions beyond the biological. How does one envision a civilization thriving in such an environment? Think about the architectural ingenuity needed. Structures built to withstand fierce sunlight on one side while also providing warmth against the bitter cold on the other. Communities might extend along the twilight zone, utilizing geothermal energy, or focusing their living spaces to offer access to water resources that could trickle down from melting ice, capturing the essence of life's resilience. Moreover, let's consider the psychological implications for beings that inhabit these planets. Living in constant light or eternal night surely shapes perception, societal norms, even cultural practices. Those on the sunny side might celebrate life's vibrancy, crafting legends rooted in warmth, while those in the darkness could honor the mysteries of the unseen, finding beauty in what others fear. As we contemplate the implications of tidally locked worlds, we unlock new avenues for understanding both our universe and ourselves. By reflecting on these magnificent yet harsh environments, we gain insight into potential forms of life beyond Earth, and perhaps learn more about our existence here. Exploring such worlds gives us a larger lens to may call home. The suns that rise and fall in our own lives, those moments that shed light on our own existence, contrasted against the shadows of struggles faced constantly. Ultimately, these tidally locked worlds invite us into a profound inquiry about adaptability, survival, and the essence of life itself. They are reminders of our planet's capabilities and fragility, reflective of the challenges that come with both light and darkness. In this dizzying cosmic ballet, we can find our place and appreciate the balance intrinsic to life, no matter where it may thrive in the universe's great tapestry. We often think about gas giants like Jupiter in our solar system as distant, colossally serene worlds, swirling with clouds and storms. But their extraterrestrial cousins, known as hot Jupiters, turn that notion on its head with their extreme and almost hostile environments. Imagine living on a planet where the sun is not just a glowing orb in the sky, but an all-consuming furnace, devouring everything in its path. Hot Jupiters are gas giants that orbit perilously close to their stars, far closer than Mercury orbits our own sun. Typically, these planets have massive atmospheres filled with hydrogen and helium, but when they're situated in such intense proximity to their stars, the conditions become deadly. The heat and radiation they experience are so extreme that they're constantly bombarded, leading to dramatic consequences for their composition and structure. Let's picture this scenario in a more relatable way. Imagine standing on the surface of a hot Jupiter. The air would be thick and hot, swirling with toxic gases. The sky might shimmer as if it's on fire, with colors that bend and warp under intense heat. Temperatures could soar to thousands of degrees Fahrenheit, making it impossible for any form of traditional life as we know it to exist. Here, any rain would evaporate before it could touch the ground, and clouds are not the soft, fluffy formations we see here on Earth. Rather, they consist of molten glass and other heavy materials, tumbling through the atmosphere at breakneck speeds. Now let's take a closer look at what happens to these planets over time. As they orbit their stars, they're subjected to colossal gravitational forces that stretch and warp them, a process known as tidal heating. This heating causes their atmospheres to react vigorously, resulting in powerful winds that can reach supersonic speeds. The air is thick and volatile, creating storms that can last for years, possibly even centuries. Amidst this chaos, something striking happens. Gas from the atmosphere starts to escape into space. Imagine a scene where you're observing one of these colossal planets from afar. You'd see bright trails of gas spiraling away, illuminated by the light of the nearby star, stretching thousands of miles into space like a glowing comet's tail. This dramatic phenomenon is not just visually stunning, it also offers significant insights into the evolution of these planets. The loss of atmosphere reveals the processes that can shape planetary bodies and their potential for fading away over eons. So, how do scientists study these fascinating entities? While we cannot physically travel to these far-off worlds, astronomers utilize advanced telescopes and methods like the transit method, where they observe dips in the light from a star as a hot Jupiter passes in front of it. By analyzing how the light changes as it filters through the planet's atmosphere, researchers can infer the compositions, temperatures, and even the weather patterns on these bizarre worlds. Interestingly, hot Jupiters also challenge our understanding of planetary formation and migration. Many of these gas giants appear to have formed far from their stars, similar to how we believe Jupiter did in our solar system. Over time, they are thought to have spiraled inward, possibly due to interactions with other planets or as a result of gravitational forces from nearby star systems. This raises intriguing questions about the formation of our own planetary neighborhood. Could Jupiter have followed a similar path? Consider the implications of hot Jupiters for potential life in the universe. The scalding environments and inhospitable conditions starkly contrast with the habitable zones we often think about when searching for life. It emphasizes our unique place in the cosmos, sparking further curiosity. If planets like Earth evolved in the quiet corners of the solar system, what else might we discover in less extreme environments? With all of this grandeur, beauty, and chaos, hot Jupiters serve as a constant reminder of the diversity in the universe and our ongoing quest to understand our place within it. The fact that such extreme worlds exist, defying logic as we understand it, not only adds to the mystery of cosmic phenomena, but also roots our own experience of planet Earth in a more profound context. Imagine gazing up at a starry sky, knowing that planets like these do exist out there, spinning through the void in a dance as old as time. As we reflect on the awe and excitement that hot Jupiters evoke, let's remain curious, questioning what we know, and eagerly await what discoveries lie beyond our reach, waiting for the universe to unveil its secrets, one gas giant at a time. As we venture deeper into the universe, we uncover some of the most intriguing and paradoxical worlds, where beauty transcends the typical notions of brightness and color. One striking example is Tries 2b, a planet shrouded in a mesmerizing darkness, reflecting nearly none of the light it encounters. Picture this: a celestial body so black it seems to swallow the very light around it. It absorbs over 99% of the sunlight that falls upon its surface, rendering it virtually invisible against the vast backdrop of space. Now you might wonder, how can something so dark be considered beautiful? It's a question rooted in our perceptions. We're often drawn to colors that are vibrant, bright, and eye-catching. However, Tries 2b, with its charcoal-like surface, challenges this convention. It invites us to reconsider our definition of beauty. Here, in the shadowy embrace of this planet, we find a beauty that is subtle, quiet, and profoundly unique. Think about it. Life on Earth is filled with moments that resonate in shades of darkness. The comfort of night, the deep mysteries of the ocean's depths, or even the quiet of an untouched forest. All of these places remind us that richness doesn't solely lie in illumination. Just as Tries 2b exists in stark contrast to shining stars, we too encounter dark moments that shape our experiences. These contrasts highlight the full spectrum of existence. Both the light and the dark play pivotal roles in creating balance in our lives. In the realm of astrophysics, the existence of dark planets sparks many questions. What drives the formation of such celestial beings? Tries 2b, for example, is a gas giant located approximately 750 light-years from Earth in the constellation Lyra. Its proximity to its star, a hot and bright type of star known as a K-dwarf, agitates its atmosphere, creating striking temperatures that soar during the day. These conditions ultimately contribute to the extraordinary darkness of the planet, as the gases present absorb light rather than reflect it. We're left to marvel at how such a planet could thrive, thriving in the very shadows that define it. When we explore the concept of dark planets, we can also consider the emotional implications they carry. They serve as a reminder that even within obscurity, there is resilience. These planets, often overlooked in the grand cosmic drama, echo the struggles we all face. They mirror our personal journeys, where we may wade through periods of uncertainty and darkness, yet still emerge transformed. Just as Trieste 2b continues its cosmic dance around its star, we too find our way, even in times when it feels like all light has dimmed. Furthermore, astronomers have detected other dark worlds that add depth to this narrative. Take, for instance, WASP 12b, another exoplanet classified as one of the darkest known. WASP 12b has a similar trait to Trieste 2b, differing slightly in its climate dynamics, but resonating with that same sense of profound beauty in darkness. Intriguingly, studies suggest it is tainted by an atmosphere of carbon, creating a light-absorbing haze that deepens its opaque nature. On these planets, we discover not just dust and gas, but also stories of survival and adaptation amidst harsh circumstances. For many of us, our existence is painted with both bright and dark hues, moments of triumph followed by challenges that feel insurmountable. Just as dark planets thrive amid the stars, so can we cultivate our strength in adversity. The universe, in all its vastness, teaches us that darkness is not something to fear. Rather, it enriches our understanding of ourselves and the world around us. As we gaze into the night sky and find ourselves captivated by the sparkling stars, let us also take a moment to acknowledge those hidden worlds, the dark planets that exist unassumingly in the cosmos. They remind us that hidden beauty often lies in the shadows, waiting to be recognized and celebrated. In our pursuit of light and clarity, may we also learn to embrace the dark moments that help define our journey. Like Trieste 2b, we can find strength in the shadows, standing resilient and beautiful even when wrapped in the cloak of darkness. And who knows what else we might discover as our technology evolves and our understanding of the cosmos deepens. For every shimmering star that lights up the sky, there may be a hidden dark planet that holds secrets we have yet to uncover. Perhaps they will teach us about balance, resilience, and the myriad forms that beauty can take. As we continue this cosmic journey, let's keep our eyes wide open, ready to embrace both the starkness of dark worlds and the brilliance of light. Imagine a world adrift in the cosmic void, a planet that once danced around a sun, but is now alone in the dark, lonely spaces between stars. These celestial outcasts, known as rogue planets, tell a story of solitude that resonates deeply with us. We may not all be a massive gas giant or rocky Earth-like planet, but the concept of drifting away from familiar places, feeling alone, or searching for our identity resonates on a personal level. Rogue planets can be thought of as the cosmic wanderers, unanchored by the gravitational ties of their parent stars, living in eternal exile. Picture this. One moment, they might be thriving in the warmth of a solar embrace, teeming with potential and possibilities. The next, through a catastrophic event such as gravitational interactions or collisions, they are cast out into the cold, unwelcoming dark. It's like being asked to leave a party just as you're starting to enjoy it. In the grand tapestry of the universe, rogue planets are the forgotten souls, slipping through the cracks of space-time without a purpose or a path. While they may seem insignificant against the vast backdrop of the galaxies, their existence raises profound questions about isolation and resilience. Each of these worlds carries with them the silent echo of their origins, a faint glow that persists long after their stellar parenting has ceased. It's a warming reminder of what they once were and the memories locked within them, reminiscent of our own experiences that shape us, though we might move through life feeling adrift. Take a moment to consider the vastness of our own human experiences. We all encounter moments of solitude and occasionally feel as though we're floating in a darkness of our own. This connection to rogue planets enables us to view them as more than just cosmic anomalies. They become symbols of existential journeys and the search for our personal meaning. Recent studies suggest that there could be billions of rogue planets roaming our galaxy alone, possibly outnumbering the stars themselves. From the perspective of our emotional experiences, it's fascinating to think about how each of these planets could represent a unique story, an isolated experience of being cast away from a once thriving solar system. The idea that so many lonely planets exist in silence like whispers lost in the void allows us to reflect on our own lives, the moments when we felt disconnected, and how those experiences shaped who we are today. Yet, there's an intriguing layer to the narrative of rogue planets that ignites a flicker of hope among their solitude, the potential for life. Just as the heat that radiates from these planets is a remnant of their birth, so too could there be guises of life hidden beneath thick layers of ice or in subterranean oceans. This notion challenges us to consider resilience and adaptability, qualities that often emerge when we find ourselves in our darkest moments. As we venture deeper into our understanding of rogue planets, let's discuss the science behind their formation and existence. Rogue planets are believed to form in a variety of ways. Some originate within star systems and are ejected due to gravitational interactions with other massive celestial bodies, or because of disturbances caused by the birth of multiple stars. Others may form from the accretion of gas and dust in the void of space, outside the influence of any star, a testament to the random and capricious nature of the cosmos. Navigating through the universe, these planets can travel immense distances. Some might drift for billions of years before encountering another gravitational field, possibly being swept back into the embrace of a star, or even colliding with another celestial body. The endless wandering of these planets can remind us of the journeys we take in life, the way we sometimes meander without a clear destination or purpose, but still harboring the heat of our experiences and memories. You might ask, what does this mean for us? The existence of rogue planets challenges our conception of belonging. They thrive despite their isolation, and often embody strength in that solitude. Just as these planets carry forward in times of adversity, we too are called to explore our capacity for resilience. Life might cast us into a darkness that feels unending, but we can ultimately emerge from our own silence with renewed understanding and warmth, seeking light and connection in our own ways. So, the next time you feel that twinge of loneliness, or find yourself wandering through a phase of life without clarity, remember the rogue planets above. They drift through the universe, cold and forgotten, yet still radiating the heat of their history. Their journey teaches us that even in solitude, there is a story worth telling, a spark of warmth that continues to glow with purpose. The cosmos is vast and beautiful, and like rogue planets, our individual journeys, though they may wind through darkness, can lead us to discover incredible wonders, both within and around us. As we look to the stars, let's take a moment to honor these silent giants that wander the universe alone. They may seem like mere blips in the grand scheme of the cosmos, but they remind us all of the strength found in solitude and the quiet resilience needed to forge our own path. Imagine standing on the surface of a distant gas giant, the ground beneath your feet soft and amorphous, shifting slightly like the gentle ebb and flow of ocean waves. Above you, the sky isn't just a simple expanse of blue. Instead, it is woven with an ethereal tapestry of colors, shimmering under the brilliant glow of alien suns. Here, the clouds are not merely made of vapor. They possess an almost mythical beauty, crafted from precious gemstones. Yes, we're talking about clouds made of rubies and sapphires. As you gaze upwards, you can't help but feel a sense of wonder. It's as if the universe has painted a masterpiece just for you. The reds of the rubies and the deep blues of the sapphires intermingle, their hues shifting in response to the light. But how do these gemstone clouds form? It begins with the planet's unique atmospheric chemistry, rich in metallic vapors that exist in abundance far beyond our own understanding of earthly environments. In these alien atmospheres, intense pressures and distinct temperatures allow these metallic elements to condense into droplets. You might be surprised to learn that what we consider a typical cloud, water vapor, is transformed here into a spectacle of color and light. Instead of raindrops, you would witness jeweled droplets, each one reflecting the planet's radiance while creating a dance of light that could rival the most stunning fireworks display on Earth. Imagine the sensation of seeing the light refracting through these raindrops as they fall, creating rainbows that don't just end in the sky, but also cascade down toward the ground, where they might leave behind traces of shimmering color. The ground might not be sand or dirt, but rather an otherworldly landscape dripping with metallic glints, each step you take eliciting a sparkle either on the surface or above your head. There's a dreamlike quality to this scenario, one that evokes a sort of longing. It's easy to relate to the allure of beauty in nature, even when it's so foreign. We often find ourselves searching for the extraordinary in our own lives, chasing after moments that take our breath away. Perhaps you've watched a sunset where the sky was painted with vibrant shades of orange and purple, or stood in awe before the northern lights. On that gas giant, you'd feel that same sense of awe magnified 1,000 times over. But the spectacle doesn't end there. The way these clouds interact with the local climate offers us even deeper insights into these alien worlds. The presence of rubies and sapphires in the atmosphere suggests a potent, complex system of chemical reactions unlike anything we know on Earth. Imagine being a scientist, eager to decode the secrets these jeweled clouds hold. What do they reveal about the conditions on these planets? How do fluctuations in atmospheric pressure affect the composition of these stunning clouds? Each drop is a mystery waiting to be unraveled, providing breadcrumbs to understanding the planet's history and potential for life. In your mind's eye, visualize how the sun would illuminate these skies, casting shadows of vibrant reds and blues, not just across the landscape, but rippling through your senses like a warm embrace. It ignites your curiosity about what life, if it exists at all, might thrive in such an environment. Creatures evolved in an ecosystem enriched by gemstone clouds could be dazzling, perhaps even bioluminescent, drawing on the colors above in vivid displays of their own. And let's take a moment to reflect on our own experiences. How often do we overlook the incredible beauty surrounding us on Earth because it feels mundane in comparison? The act of looking up, whether at a starry night or a stormy sky, has always evoked feelings of hope, wonder, and longing. The idea that somewhere, in another realm, nature crafts its own versions of beauty can stir our imaginations. These gemstone clouds remind us of the creativity of the universe, challenging us to find the miraculous in our everyday lives. The importance of appreciating this beauty extends beyond just the visuals. It serves as a metaphor for our own lives. Much like the gemstone clouds that arise from a complex interplay of elements, our moments of triumph and joy often emerge from intricate situations we encounter. Life's brilliance can emerge from the darkest developments, and those sparkling moments we cherish are the jewels of our existence. In delving deeper, you realize there's a deeper philosophical angle here. If gas giants with gemstone clouds exist, what does that say about our place in the universe? Are we just small observers of this grandeur, or are we part of a larger narrative? The thought that gems may suspend above alien landscapes suggests there's an infinite number of stories waiting in the cosmos, a narrative that includes us and our quest for knowledge, for beauty, and for connection. As you ponder this perspective, take a moment to allow your thoughts to wander. Picture yourself on that gas giant again, feeling awash in a sea of wonder. The clouds above might serve as reminders that exploration, whether on the grandest scales of space or in the depths of our own personal journeys, often leads us to incredible discoveries of the universe and our place within it. In an unfathomable cosmos, even the notion of gemstone clouds fuels our hopes and dreams. They beckon us to look up, not just at the skies, but at our own aspirations. So, the next time you find yourself stargazing or pondering nature's mysteries, let your thoughts drift to those distant, gem-laden skies. Embrace the enchantment they represent and allow it to inspire you to find the extraordinary within the familiar, illuminating the path ahead. Each shimmering moment in our world may be less rare than we think. It could just take a perspective shift to see it. Carry that inspiration with you as you continue to explore, both in the cosmos and deep within your soul. As we peer into the vastness of the cosmos, one of the most fascinating classes of planets we encounter are the so-called super-Earths. Imagine a planet that's larger than our own, yet significantly smaller than giants like Neptune, a world that evokes a sense of curiosity and wonder. What does a super-Earth mean for the possibilities of life beyond our own planet? To paint a clearer picture, let's delve into what defines a super-Earth and what makes them so unique in our quest for extraterrestrial life. Typically, these planets have a mass between 1 and 10 times that of Earth. While this may make them seem daunting, they possess qualities that could make them more hospitable than our home. One of the remarkable features of many super-Earths is their potential for thick atmospheres. With a larger gravitational pull, they can retain gases more effectively than our planet. This means they might boast air pressure that could create a more stable environment. Picture yourself walking on a planet where the air is rich, perhaps even fresh, similar to the crispness of a mountain atmosphere, but saturating the entire environment. Such conditions could provide the right chemicals and warmth to support various forms of life. But the fun doesn't stop at atmospheric conditions. Many super-Earths are theorized to have gentle gravity. Though they may be more massive, the way their mass is distributed can result in a more comfortable gravitational pull than you might expect. This gentler gravity could potentially allow life forms to grow larger and flourish in ways we've never seen before. Imagine ecosystems teeming with vibrant flora and fauna that could rival, if not surpass, our own. Then there's the idea of stable climates. Unlike Earth, which is subject to the whims of weather patterns that can shift drastically, several super-Earths could maintain a more consistent climate over extensive periods. The thought of an environment where temperatures are moderate year-round opens a floodgate of possibilities. Habitats that encourage diverse biological developments, perhaps even intelligent life. Consider how climate stability impacts our own experiences here on Earth. Our lives are profoundly shaped by the seasons and daily weather changes. Food production, clothing choices, daily routines, all hinge on our environment. Now think about a world where you wouldn't have to worry about harsh winters or blistering summers, but instead can rely on a reliable, temperate climate instead. How different, yet familiar, would life on a super Earth feel? Moreover, when we examine strong candidates for super Earths within our own galaxy, we're particularly intrigued by the TRAPPIST-1 system. Each of the 7 Earth-sized planets orbiting this dwarf star features characteristics that suggest they could very well possess the attributes for life. Temperatures that permit liquid water, stable atmospheres, and chemical elements necessary for biological processes. This encourages us to imagine what it might be like to be an inhabitant on one of these potential worlds. As we ponder the possibilities, it's essential to reflect on our own place in the universe. The prospect of establishing contact with intelligent life that could exist on these super Earths beckons feelings of hope and wonder. It's not just about seeking out new worlds, it's about understanding what unites all life across the cosmos. Would our experiences be different? Or is there a universal language of existence that transcends planets? The study of super-Earths isn't just an academic pursuit. It's a deeply personal quest, one that speaks to our intrinsic desire to explore and understand our origins. Our planet has given birth to diverse ecosystems and complex life, and now we find ourselves at the threshold of discovering worlds that could not only reflect our own, but expand upon it in extraordinary ways. So when we think about super-Earths, we aren't just considering distant celestial bodies. We're exploring the possibility of new homes, new forms of life, and new knowledge. Each discovery brings us closer to answering the question that has echoed through time: are we alone in the universe? And if super-Earths exist, perhaps within them lie answers waiting to be uncovered. This exploration is not merely scientific, it's about imagining the extraordinary and contemplating the infinite. With the technology we are developing and the new discoveries being made, the idea of reaching these super-Earths transitions from a distant dream to a tangible goal. As we continue our journey across the stars, let's keep our hearts and minds open to the endless possibilities that await. Each step we take not only enhances our understanding of the universe, but also strengthens our connection to each other and our shared destiny. Imagine a planet where a single day feels like a blink of an eye. What if I told you that there are worlds out there where years pass in what we can barely consider a half day? Welcome to the realm of fast-orbiting planets, celestial bodies that dance around their stars so quickly that time takes on a whole new meaning. Take, for instance, Kepler 78b. This exoplanet, a mere 400 light-years away from us, has an orbital period of just 8.5 hours. You heard that right. In the time it takes to binge-watch a few episodes of your favorite show, this planet completes an entire revolution around its star. That means a full year on Kepler 78b is only about 13 Earth hours long. It's almost impossible to grasp how rapidly it zooms through its solar system. Now, let's consider what it must be like on the surface of Kepler 78b. Orbiting so close to its star, this planet endures intense heat. The temperatures are so extreme that the very landscape is transformed. Instead of solid ground, you would find vast, glowing seas of lava. The surface is in a constant state of flux, bubbling and boiling in the relentless warmth. Imagine standing on the edge of a lake, and rather than calm waters reflecting the sky, you're greeted by a roiling molten sea shimmering under the glow of its star. For us Earthlings, it boggles the mind to think about living on such a planet. Is there any semblance of a day-night cycle? How would you structure your life on a planet where it feels like you're constantly racing against time? Would you wake up to watch the fiery lava waves in the early morning and sleep just a few hours later? It shifts our understanding of time, doesn't it? Here on Earth, a single day can sometimes feel like a marathon. But on Kepler 78b, everything moves in fast forward. The physics of fast-orbiting planets can also lead to fascinating phenomena. Kepler 78b falls into a category known as hot Jupiters. But since it's a rocky planet, it behaves a bit differently. The gravitational forces at play distort its shape, leading to potentially interesting atmospheric conditions as well. This could mean that, while the surface is molten, the atmosphere above might be swirling with gases that create dynamic weather patterns. Imagine storms that whip across the sky like nothing we've ever seen, influenced by the constant proximity to the star and the reality of day occurring at such a rapid pace. As we dive deeper into the study of exoplanets, planets like Kepler 78b serve as reminders of the incredible diversity that exists beyond our solar system. They challenge our definitions of habitability and life itself. Could any form of life adapt to such conditions? It's a conversation that ignites the imagination. With the surface engulfed in lava and the atmosphere continuously shifting, one can't help but wonder what kinds of ecosystems might exist, if any. Would life, if it exists, emerge from the furious seas rather than from solid ground as we know it? But fast-orbiting planets are not just curiosities. They are significant in the quest for knowledge about planetary formation and evolution. The extreme conditions we observe give scientists insight into how different planetary systems develop. Each lava-spewing surface, every short orbit, helps refine our understanding of the delicate balance between a planet's distance from its star and its capacity to sustain an environment. Imagine being part of a vibrant community that captures data about such distant worlds. It's like being on the front lines of a cosmic discovery. What does this mean for our search for life elsewhere in the universe? Even if we can't imagine living on a planet like Kepler 78b, every discovery contributes to a broader tapestry of knowledge that helps narrow down the types of celestial bodies that could potentially host life. Understanding these inhospitable worlds is crucial as we look for the oh-so-elusive Earth-like planets that might harbor life as we know it. The universe is an intricate puzzle, and each piece, including these fast-moving planets, plays a significant role. In summary, fast-orbiting planets like Kepler 78b twist our conceptions of time, environment, and the very definition of livable. They push the envelope of our imagination. As we learn more about these extraordinary worlds, we move closer to understanding not just where we fit into the cosmos, but what it means to exist at all. Whether it's racing through their orbits or their rugged, lava-drenched surfaces, these planets remind us of the limitless possibilities the universe holds. beckoning us to explore further, think deeper, and dream bigger. As we delve into the fascinating world of planets orbiting dead stars, it's almost poetic to consider that even in death, some celestial bodies continue to exist in the shadow of their once vibrant suns. Imagine a night sky devoid of the brilliant glow of a star, replaced instead by the faint, almost ghostly light of a white dwarf or a neutron star. In this silent and cold expanse, planets still do their graceful dance around these remnants, hearkening back to a time when life, warmth, and light thrived. Our journey begins with the white dwarf, a stellar remnant that has shed its outer layers, leaving behind a dense core that continues to radiate residual heat. Picture this: a planet, perhaps a rocky world similar to Earth, has loved its sun for billions of years. Together, they faced cosmic storms, solar flares, and the breathtaking beauty of distant galaxies. But then, as all stars eventually do, the star reaches the end of its life cycle. It exhausts its nuclear fuel and expands into a red giant before ultimately collapsing into a white dwarf. While the planet's sun fades, does life still cling to existence? As this white dwarf cools and dims over millions of years, the planet, now an orphan of sorts, remains in orbit, desperately holding on to the memory of its former sun. It's an almost heartbreaking image, isn't it? Think about how profound it would be for a planet to experience such loss. Once bathed in the warmth of its sun, now forced to adapt to a harsher, colder reality. This planet may now be a desolate world, but it also embodies resilience, surviving in the unforgiving darkness, waiting patiently in the vast cosmic sea. In some cases, these planets may even harbor secrets of their own. Imagine a conversation with a scientist who speaks of exoplanets within this unique realm. They might describe discovering remnants of atmospheres or signs of water on these planets orbiting white dwarfs. The question arises: can life exist in these cold, dim environments? Surprisingly, studies suggest that if conditions are right, such worlds could host microbial life, or at least preserve the building blocks that once supported it. It's like the echo of life, clinging to the hope of a possible revival, a testament to cosmic endurance. Moving on to more exotic remnants, we encounter neutron stars, the densest objects in the universe. When a massive star implodes, it can generate a neutron star, and just like white dwarfs, these remnants can have planets in close orbit. Now, imagine a planet whirling around such an intense gravitational field. The forces at play are unfathomable. These worlds must withstand immense pressure and high levels of radiation as they revolve around a pulsar, a type of neutron star that sends beams of electromagnetic radiation, much like a cosmic lighthouse. Here, the thought of life brings to mind a chilling, awe-inspiring image. What kind of beings may evolve to thrive in such a hostile environment? Or could this be a world where life never got the chance to develop, only to remain a barren landscape, sculpted by time and cosmic tragedy? These planets, nestled in an eerie silence, remind us of the strange and mysterious possibilities of the universe. As we ponder these scenarios, we must embrace the human aspect of this cosmic tale. The idea of loss, survival, and resilience is something we can all relate to. Think of times in your own life when you felt abandoned or faced challenges that seemed insurmountable. Perhaps you imagined a light at the end of the tunnel, a flicker of hope continually urging you forward. Just like the planets around dead stars, we too orbit our own ghosts, finding ways to persist in the face of adversity. The universe is vast, and within its mysteries lies a certain comfort. Even in the cold, dark aftermath of stellar death, life, whether enduring or nascent, found a way to exist. It's a reminder that endings don't always spell the end. They can also be a catalyst for new beginnings. The planets around dead stars stand as a testament to resilience in the cosmos, echoing the narrative of survival we each carry in our hearts. Lastly, let's reflect on what this means for our understanding of life beyond Earth. As we continue probing these celestial bodies, seeking signs of life in the most unexpected places, we draw closer to understanding our own existence and place in the universe. The silence of these planets offers a beautiful paradox. It's a quiet reminder that even in death, the cosmos breathes life, crafting stories of endurance that extend far beyond any single star. So, as we conclude this exploration of planets lingering in the shadows of fallen stars, let's carry with us the messages of hope, survival, and the perpetual quest for light amid darkness. Just as these worlds turn in their silent dance, let us keep searching for our own lights, regardless of how faint they may seem in the vast universe around us. As we wrap up our exploration of these incredible planets, let's take a moment to reflect on the stories each one tells. From the blazing storms of Jupiter to the frozen landscapes of Neptune, every celestial body is a testament to the raw beauty of creation and the endurance of time itself. These planets remind us that, much like them, we too have our own unique journeys, filled with challenges and triumphs. So, as you close your eyes tonight, think of the swirling clouds of gas and the icy rings that adorn these distant worlds. Let your imagination drift among the stars and allow that sense of wonder to carry you into sleep. Remember, the universe is a boundless expanse, rich with surprises waiting to be uncovered. Embrace your curiosity. It's a precious compass guiding you through the cosmos of endless possibilities. Sweet dreams among the stardust.